Ralph Wiggum is absolutely blowing up. We made a video about it last year, and since then, it's all anyone is talking about on Twitter. Matt Pocock has made loads of videos on it, Ryan Carson has written a very popular article on it, and Razmike has built on it with his Ralphie bash script. But is everyone doing it wrong? The creator has already said that some implementations are incorrect. So what's the correct way to do it? And why is Ralph currently the best way to build software with AI? Hit subscribe and let's get into it. The Ralph Loop was created by Jeff Huntley and written about way back in June last year. It is essentially a bash loop that gives an AI agent the exact same prompt over and over again. But it's genius on so many levels because it lets the AI agent work in its smartest mode, which is the mode where it has as little context as possible. Take a look at this. So let's imagine this is the total context window for an agent. From 0 to about 30% is what we'll call the smart zone, which is where the agent performs the best. From about 30 to 60%, it still performs really well. And from 60% onwards, so 60, 70, 80, 90, that's when it starts to degrade. We'll call it the dumb zone. Now, these numbers aren't set in stone and could be different per model. So the smart zone for a certain model could be 40, 50%, but usually over 80% context window, that's when the dumbness starts to begin. So for Claude Sonnet or Opus, the typical tokens for a context window is 200,000. So we can say the first 60 is the smart zone, the next 60 is still okay, but not as good as the first 60k tokens, and then the last 80k, it doesn't seem to perform as well. Now, this is my personal experience with this model. You might have had other experiences. And so the reason for this is because the model itself is what we call autoregressive, meaning it has to look at the previous tokens to predict the next one. And if you have loads and loads of tokens, it has to go through a lot of them to find out the important bits that are relevant to the next task at hand. Now let's focus on the first 30%. Even before you write your first prompt, there are some things that get added to the context window automatically. First is the system prompt, and then the system tools. These on a typical Claude model take 8.3% and 1.4% of the context. So almost 10% of this 30. And then if you have skills, that can get added. And also if you have custom MCP tools. Finally, if you have an agent's MD file, that gets added too. And the larger, of course, for any of these things, so the larger the MD file, the more tokens it will take up. And this is all even before you've added your own prompt. So in general, it's best to keep this section as small as possible. So have less tools, have less skills, and have less in your agent's MD file so that the model is working at its most optimum context. And to get an idea of exactly how much 60k is, if we were to get the whole script of Star Wars A New Hope, that is about 54,000 tokens in GPT-5. So roughly this amount. Now, you may be wondering, what about compaction? Can that help with this whole process? And we'll talk about that a bit later. But now let's move on to exactly how Ralph can help with this. So the benefit of Ralph is that you focus on one goal per context window. So the whole 200k context window, we can dedicate that to one goal or one task. And the way we do that is we write a prompt that will first say inspect the plan MD file. This contains the tasks to be done. So something like create the front end, create the back end, do the database, and so on. That is a very high level example. Of course, you'd go way more detailed if you were doing Ralph and more granular, but we'll stick with that example for now. So this prompt will tell the agents to pick the most important task, then make those changes. After making those changes, run and even push and commit those changes, as well as doing a test. And once you're done with those, once the tests have passed, then tick the task as done in the plan MD file and do that again. So the agent will keep looking for the most important task to do until it's completed all the tasks. Now, actually, let me take that back, because you could keep having the Ralph loop go over and over again, even if it has completed all the tasks. And the benefit of that is that it may even find things to fix or find features to add that don't exist in the plan MD file. But if it is going off the rails, the benefit of having Ralph is that you can stop the whole process whenever you want, adjust the prompt MD file, and then run the whole process again. And Ralph makes this so simple because this whole process is executed in one single bash while loop. So here it just cats the prompt MD file, so prints it to the agent, and then runs Claude in YOLO mode. Of course, the flag isn't YOLO, it's dangerously skip permissions, but for the sake of space, I've kept it short. And what makes Ralph special is that it's outside of the model's control. So the model can't control when to stop Ralph, it will just keep going. And that way you can ensure that when a new task runs or when a new prompt is triggered, the context, so here, is pretty much where it is when you first open the agent. So this is fresh, it doesn't have any compaction, it doesn't have anything added, so each new task gets the most amount of context and uses the model in its most smart or most optimal context window state. Basically, compaction is where the agent will look at all the tokens that have been written in the context window and pick out the most important bits for the next prompt. So it will pick what it thinks is most important, but it doesn't know what is actually most important. Therefore, compaction might lose some critical information and make your project not work as expected. Anyway, now that we've seen the canonical Ralph Loop implementation from the creator, this helps us see why other implementations are different. Let's take a look at the Anthropic implementation, which uses a / command to run Ralph inside of Claude code, has max iterations, and a completion promise. So the problem with this specific Ralph Wiggum plugin is the fact that it compacts the information when it's moving on to the next task. So if it finishes one task and reruns the prompt, instead of completely resetting the context window, it compacts what was previously done, therefore could lose some vital information. There's also the slight issue of having max iterations and a completion promise, because sometimes it's nice to just let Ralph keep going. It can find very interesting things to fix that you wouldn't have thought of before, and if you watch it, so be a human on the loop, you may see patterns, good or bad, from a specific model that you can tweak and enhance in your original prompt. If we take a look at Ryan Carson's approach to the Ralph loop, we can see here that it's not quite canonical, simply because on each loop, it has the possibility of adjusting or adding to the agents.md file. Now, depending on the system prompt or any user prompts you've added to the model, in my experience, by default, models can be very wordy. And so if on each iteration, you're adding to the agents.md file, which gets added to the context at the beginning of each user prompt, then you're just adding more tokens into the context window, pushing the model into a place where it could potentially give you dumb results. But the fact that people are making their own scripts from the basic Ralph Loop bash script is a testament to how simple and easy it is to understand. And although there is a canonical way of doing Ralph, I think it's okay for developers, teams, and companies to tweak it to their specific use case. For example, I love the fact that in RazMike's Ralphie script, there's a way to run parallel Ralphs, and also the fact that you can use the agent browser tool from Vercel to do browser testing. I also love the fact that in Matt Pocock's version of Ralph, he adds tasks or things to do as GitHub issues, and the Ralph loop will pick the most important one, work on it, and mark it as done when it's complete before working on the next one, which I think is really clever. I think the power and simplicity of Ralph means that it's going to stick around for a very long time, and you also may see a lot of iterations and improvements from it. I really like the way Jeffrey is taking this with his Loom and Weaver project, where he wants to create a way to make software autonomously and correctly. But with all these Ralphs autonomously creating new software, you need a way to search for errors and make sure they get fixed. This is where BetterStack comes in, because not only can it ingest logs and filter out errors from them, but it can also handle error tracking on the front end. So with this MCP server, you can ask an agent to specifically pick out errors from the front end or back end, instead of reading through the whole log, which in turn reduces the context window. So go and check out BetterStack and let me know what you think in the comments.